Hey again, we're out in the boat today. I'm going to go over what I have got going on in the hull here, and we're going to talk about the electronics package that I built for the boat. So this boat was originally a carbureted 4-cylinder, so there was basically nothing in here that could be used to run an EFI engine. I did retain most of the factory wiring just for the stuff for like the horn and the bilge pump and lights and some of the gauges and stuff like that, but basically everything for to run the engine had to be built from scratch. So it's really not any different than building, an engine harness for like a race car or something like that. But so we got battery over here running up to our little cutoff switch box that I built. It turns off power to pretty much everything in the boat. And then we have our little electronics board that I built underneath the gunnel here. So we have a Pro EFI 128 engine management system. So I chose this engine management system because I'm familiar with it. It's the same engine management system that I run in my E30. So I'm used to the software and all of that. These are just really like robust, waterproof hardware that pretty much never fails. And that's a good thing for a marine application. I think these ECUs were actually originally designed for offshore racing boats. I heard that from somebody once. Don't quote me on that, I guess. But so we got this board here with a row of waterproof relays on the top, a marine grade fuse panel there. This little red 3D printed box is a little electronic module that I wired in here to control the trim and tilt function on the motor. So it keeps the outdrive from tilting up too far when the engine is running, so you don't hyperextend the U-joints in the drive line. And then it also prevents the starter from working if the outdrive is tilted up too far. So I'm going to do a separate video on that just because it's kind of complicated, and I think that might help somebody else that's doing like a marine conversion and doesn't have like the original Volvo Penta module that they use to do that in a factory boat. But yeah, so just got our engine wiring harness wrapping around the back of the transom to the motor. There's a sub harness that's going around over here to our fuel tank. Sub harness that's going forward in the boat up to like the instrument cluster and our tuning cable and our CAN module and throttle and all of that stuff. Our row of relays back there, we just got like main power and a relay for the coils and injectors and stuff like that. There's one relay in there that works with the trim tilt function to depower the starter motor and trim pump when we don't want it. And then there is a relay up there that I wired in here to run a water methanol pump, even though I don't think I'm actually going to put the water methanol pump in here, but it's already pre-wired for it. And then over here underneath the bundle of wires, there's a boost control solenoid for our turbo. So back there, this connector is for our wideband oxygen sensor. Coming around over on this side of the motor to our fuel tank stuff, I got our flex fuel sensor, fuel pressure sensor, map sensor, wiring for our fuel pump, the fuel level gauge, engine wiring harness. Of course, we got the wiring for the starter. We got NOx sensors. This is a coolant temperature sensor for the instrument cluster. This is a coolant pressure sensor going to the ECU so we can monitor the coolant pressure. And you can actually use that as a fail-safe. If you start to push a head gasket, the coolant pressure will start to climb out of control, and you can monitor that and automatically basically shut the engine down if you're starting to lift the cylinder head. And then this is the coolant temperature sensor for the ECU. We got this oil pressure sensor for the ECU. This is an oil pressure sensor for the instrument cluster. Front and rear NOx sensors, the cam position sensor, the Vanos wire. We got our crank position sensor here on the front. This is going to go to the turbine drive pressure sensor. So Pro EFI actually uses the exhaust back pressure as part of the fueling algorithm. And then you can also set up fail safes for that too, that if the exhaust back pressure gets too high, it will dethrottle the engine. This is our fuel injector harness. I did convert, or I guess I didn't convert anything. I built the harness from scratch, so I wired it for Audi R8 red top smart coils. I use the same coils in my ECU on my E30, and I like them a lot. They will run up to extremely high boost pressures without blowing out, and you can run big spark gaps and stuff with them and not a problem. So I like those, and they look really cool. As you can see here, we got a drive-by-wire throttle wired in here. This throttle is off of a 3.6 liter GM V6, like a GMC Acadia. I use this same throttle on my E30 as well, and I made this little adapter plate here that sandwiches between the throttle and the stock intake manifold to mount that drive-by-wire throttle. So up here in the hole, I just put a 12-volt outlet and USB port in there the other day so I can charge my laptop and my phone. I'll probably be upgrading that radio in there as well. Over on this side, I just wired in a Garmin GPS and sonar in here. Of course, this is a lake boat, so you really need to be careful about depth and whatever, because you can run over sandbars and stuff. I did remove the original gauges that were in here. You know, they're pretty crappy old 30-year-old boat gauges and just looked outdated. So I got this new set of electronic gauges off of eBay. Got our fuel level voltage. This is a GPS speedometer, so we don't have to have the pitot tube running to the back of the outdrive to get speed over the water. It just runs off a GPS sensor. The tachometer here is driven by the ECU, so the ECU outputs a tach signal to this gauge. Got our oil pressure and coolant temp. This gauge over here in the corner is the trim gauge. So this actually shows you like a visual display of how far up and down your outdrive on your motor is tilted. So like how far into the water the prop is. And then this also supplies the voltage signal that goes back to the trim sensor on the outdrive, and that's also used for that trim tilt module on the electrical panel back here. So yeah, I'm going to be making a separate video on that trim tilt module. I think I mentioned that already, but I'll explain that in more detail, how that works. Then we got our tuning cable for our laptop here. We got this Pro EFI CAN display gauge. So this just runs off the CAN bus on the ECU. So you can configure this to display any CAN communicatable setting that or parameter that the ECU is transmitting. So it will show all the like sensor values, and it will also give you any like sensor out of limit alarms, or basically any of the check engine light type of functions that the ECU is capable of doing. Factory ignition switch works for everything. Got the factory switches to run the stuff in the boat. So this is the engine compartment fan, this is the bilge pump, this is like the navigation lights, horn. Then we got this boost gauge here is the original boost gauge that I bought for my E30, like, you know, almost 20 years ago now. And I just thought it was kind of funny to put that I put this in here. It's been sitting in a box for like 15 years now. You know, when I originally bought this boost gauge, I remember thinking to myself, like, we're never going to be running anything over 15 pounds of boost in this car. Like that, this is going to be plenty good. We'll never need anything bigger than that. And of course, that lasted for like a year. And then I had like a 20-pound boost gauge, and then I had a 30-pound boost gauge, and now I have a 60-pound boost gauge. But so I just thought it would be kind of cool to put that in here. Up here, this switch on the top here, this is our boost level. So we can set up 5 boost tables in the ECU and switch them on the fly with that switch. Actually, on this display gauge here, the iBoost position, when I move this switch, you'll see that change. So I don't really know what is going to be like a reasonable level of power in this boat. So, you know, maybe we don't need 5 boost levels. Maybe maybe we'll only use 2 or 3 of them. But we'll see on that. But this is just going to be kind of like a family fun boat type of deal. And I don't know if like what is it going to be a safe and sane amount of power in here? Maybe that's going to be 300 horsepower, maybe it's going to be 400, maybe it's going to be 500. I don't know. We'll find that out when we get there, and we'll just have to test and, you know, see how it reacts. But you know, I want this thing to be like easy to drive and safe and not, you know, a death trap. So that's the reason why I decided to do the electronic throttle on this setup along with this iBoost switch. So in the Pro EFI, you can select like you can change from like a high octane to a low octane tune on here. And you can also build like maximum allowable boost tables on these 5 switch positions. So like in theory, I could have setting number 1 would be like, I can have set up as like a valet mode. So it would only allow it would only allow the engine to go up to like basically 0 pounds of boost. And if it starts making any boosts at all, it will just hit the boost cut and you'd have to pull back on the throttle to get it to stop chopping out. So I can have like setting 1 can be like valet mode. Setting 2 might be like, you know, 7 pounds of boost on pump gas. Setting 3 might be 10 pounds of boost on pump gas. Setting 4 and 5 might be race gas tunes. We'll see on that. And then along with that, like I was mentioning with the drive-by-wire throttle, you can also set up like a maximum allowable throttle position table in the ECU. So I could actually set up a tune in here so that when you push the throttle all the way forward, it will only open the throttle on the engine like 40% or 50% or whatever you want it to be. So like I can set up a tune in here that would be like safe for my kids to be able to drive, where, you know, they could you know, safely sit in my lap here in the front seat and drive the boat and not have to worry about getting out of control. So that's the reason why I wanted to do all the electronic throttle stuff, is just because it gives me so much more options for safety and control and tunability. We got our safety tether switch here. So this goes to like a lanyard around your arm. And if you pull out this cable, it will shut off this switch here and shut down the engine. So if you get out of control and fall out of the seat or something like that, the boat will just shut off. Like I mentioned, the factory ignition switch and all of that, all the factory wiring basically all works. So our shift throttle mechanism here, I did take the shifter throttle mechanism out of the old Forester boat that I scrapped. The Mercruiser and Volvo Penta systems use like slightly different shifting mechanisms and throttle mechanisms between the two of them. So I just wanted to make sure that everything was going to work and be compatible and not be a pain in the butt to make it work. So I just decided I'll just keep the Volvo Penta stuff in here. And then to make this a drive-by-wire system, what I did here is basically I removed the original cable throttle that would have went to the carburetor, and I made a bracket up here that mounts an accelerator pedal position sensor from a car. I can't remember what kind of car it came from. I think it might have been a Nissan 370Z. But and then this little link bar with the 2 little turnbuckles on it goes from where the original cable throttle would have attached up to that sensor. And then in the back here is the shift cable that shifts you from forward to reverse. So if you're not familiar with boat stuff, like that's shifting into reverse. So this would be idle in reverse, and that would be full throttle in reverse. And then that would be idle and forward, full throttle and forward. And you might be able to hear the throttle is working back there because I have the ignition on. But yeah, so that was actually pretty easy to do. Just had to make a couple little brackets and figure out the geometry, and it wasn't too hard. But yep, so everything working back there. So our trim tilt motor back here, this is a hydraulic motor for the trim on the engine. As soon as I get this mock-up engine out of here, I'll be moving that trim tilt motor over here in front of the gas tank. But so the next steps that we have to do here to get this running, I think I'm done now with all the electronics. Everything is wired in, everything seems to be working. I've calibrated all the sensors. Everything that I can tell seems to be functioning. So I think we're done with this mock-up engine and we can take this out of here. So the next steps, we need to carpet the hull in here and build an engine for this. So I have all the parts to put the engine together, and I'm hoping to get that done very quickly. And like I said, also we need to carpet the floor on the boat here. I need to fiberglass in this little spot in the floor that I had to cut out. I actually really didn't need to cut out here, but the harmonic damper on the motor was like 1/4 of an inch away from the floor. And this, the water pump was also pretty close to the floor as well. So I just wanted there to be a little extra clearance. So I'll just glass that up and then get the carpet in here. I'm not looking forward to doing that. But once we've got carpet in, we can screw down the fuel tank for good, get the real engine built and get that set in here. Then we can hang a turbo on it and gonna build the exhaust system that's gonna go around to the exhaust. So it's gonna have like a wet exhaust system with like a dual walled downpipe, like a water cooled downpipe that dumps water into the exhaust like a boat normally does and goes out through the through pop exhaust. And then over here on this side of the engine bay over here, I've got a air to water intercooler that I built for this that's already done, and a engine like water to water heat exchanger. So we are going to run like antifreeze in this motor, and it's going to circulate that through a water to water heat exchanger that's cooled by the lake water. Yep, so know what we got to do, and now we just got to do it. So my goal is to have this running in the next couple months. We'll see how that works out. Depends on what I'm going to end up be doing with work and all of that, but that's my goal. I would really like to have this out on the 4th of July. I have a camping trip scheduled for that weekend. But yeah, so I guess that's about all I have to say for today. Next video should be either carpet or engine, and then we'll be off to the races after that, I think. Then we got to just get the seats put in here, front and rear seats. Eventually I got to build a deck to go over the top of the engine compartment back here, but that might be a longer term goal. First thing, we got to just get it running and get it out on the lake and start having some fun with it. But yeah, so thanks for tuning in. All right, bye.